In question 2 of this exercise, we have to fill in the blanks for each of the 4 given statements. So the first statement says, a tangent to a circle intersects it in blank points. So basically this is asking a tangent to a circle intersects it in how many points. So for any circle, we know that if we draw a tangent to that circle, it just touches that circle. So for this circle that you see here, let's draw a tangent. So this is one possible tangent for this circle, and it just touches the circle at this point. Let's call this point P, and this means that you can think of the tangent touching the circle as the tangent intersecting the circle at exactly 1 point. Okay, so the answer for this question will be 1. The tangent intersects the circle in exactly 1 point. Then in part 2, statement 2, it says a line intersecting a circle in 2 points is called a dash. So for any circle, if a line just touches that circle, then it is a tangent. But if it intersects the circle in 2 points, then what is it called? So let's say this line that I've drawn for this circle, it intersects the circle at 2 points A and B. What would we call any such line? Well, any such line is called a secant of the circle. Okay, so secant is the answer for part 2. Then we come to statement 3, which says a circle can have dash parallel tangents at the most. So I want you to visualize this situation carefully. How many parallel tangents do you think a circle can have? So let me draw one tangent for this circle. So let's say this tangent here. Now, how many other tangents can this circle have which are parallel to this tangent? So if this is the point of contact A for the first tangent, then it's easy to see that this circle will have exactly one more tangent that's parallel to this first tangent. And how do you find that tangent? Well, you draw the diameter through the point A. The diameter will pass through the center O of the circle. So let's draw the diameter by joining AO and extending it to the other side. And then let's say that this point here is the point B, the opposite end point of the diameter. Now, if you draw a tangent to the point B, like this, okay, let me draw it again to make it parallel to the first one. Then now you can see that the tangents at A and B, they are parallel. So this means that for any tangent, there can be exactly one more parallel tangent to that tangent. Or in other words, a circle can have 2 parallel tangents at the most. Okay, so that is the answer for part 3. Let me also help you visualize this part better by showing you a simulation of this situation. So here's a simulation which shows a circle with center O and a diameter AB, and the tangents at A and B are drawn, and you can see that they are parallel. Now if I vary the diameter, let's say I move the point A like this, you can see that the tangents at the endpoints of the diameter continue to be parallel. Okay, and you can see that you can draw at the most 2 parallel tangents to the circle. So if you have any tangent, there can be exactly one more tangent that is parallel to the circle. So this is how you can think of part 3. Then lastly we come to statement 4, which says that the common point of a tangent to a circle and the circle is called blank. So if you draw any tangent to a circle, it intersects the circle at exactly 1 point, or it touches the circle. So that point, what do we call this point? Well, this point is called the point of contact. The point at which the tangent touches the circle is called the point of contact. So that's the answer for statement 4, point of contact. Okay, so this completes question number 2.